So in problem number 1, I would probably start by identifying the amplitude and the midline for each of the graphs. So the midline here is at -3, and the amplitude is +2, and I would kind of check to see if there's a graph that fits that. Equation that fits that. In problem number, or letter B, the top is at 1, the bottom is at -5. So that means the midline would be at -2. So we're looking at -2 is the midline. And it goes up 3 and down 3. In problem C, the top of the graph is 1, the bottom of the graph is -1. So the midline is going to be at 0. And the amplitude will be 1 for each of these. And then problem D, the top of the graph is at 1, the bottom of the graph is at -1. So that means the midline is at 0 with an amplitude of 1 as well. So based on the information, graph A has to be the equation for number 2. So the amplitude is 2 and the midline is -3. And graph B has to be graph 4, again because the amplitude is 3 and the midline is -2 or -2. So for the rest of them, we're looking at a sine graph or a cosine graph. So the next step is looking at which sine is C sine or C cosine. Can't do both. Or is both. And then go from there, try to use the information, try to figure out which of the equations fit. So let's see if in each of the equations here, if C, for example, is just a cosine graph, or if it's a sine and cosine. Keep in mind those two graphs have the same shape. It's just the starting point on the y-axis is in different locations. When I look at problem or graph D, cosine actually goes in reverse of what I'm seeing. So that means that this here is basically this graph being flipped over. So problem 1 is actually a cosine graph with a negative amplitude. So basically every answer is its opposite of what was originally. So number 1 is graph D. So if I look at graph C, I would map in the same thing I just did for cosine. The graph itself actually has, this could be a cosine graph that has been shifted. And it's been shifted pi/2 to the left. So that would be like a negative pi/2. So if I would look for an equation that has pi/2, and this would be a cosine graph, very similar to the green graph I mapped in problem D. So that would mean that problem 3 should be graph C. Now, if you haven't done problem 5 and 6 yet, what I would suggest doing is map in the sine graph over C and D, and then see which one works. All right, so hopefully your graph looks something like this. So sine starts at 0, goes up to 1 at pi/2, back down to 0 at pi, and so on. So if I wanted to match up the graph, I would either need to move the original graph in power pi to the left to match it up, or an entire pi to the right to match it up. And we come up the top half would match up the bottom half. Mind the sine graph continues on, but it's a movement of pi. So that would be problem 6 is graph C. And then for this one, last problem here, I need to move it pi over 2. Now again, I could be pi over 2 to the left or pi over 2 to the right, depending again which way and which equation or example they're giving me. And so problem 5, they're showing that shift of pi over 2. And so D would be problem 5. All right, so I went ahead and did the amplitude in the midline. And so for both problems, the amplitude and midline are going to be the same. So I'm just going to start with y is equal to, again, the amplitude is 10 plus 15 times the sine of theta minus something. I forget what that adjustment is. Y is equal to 10 plus 15. Again, the other parenthesis I put for sine something necessary, but the one second parenthesis is. So I can put the two sets of parentheses or just a single set of parentheses. And then we have to decide based on the graph how much do we need to shift it. So for example, I went ahead and marked the top of the graph here is using 3 pi over 4, and the bottom of the graph is using 7 pi over 4. So if you think about where sine and cosine, or the top and bottom would be, if you weren't shifting it, what values would they line up with in terms of 0 radians, 2 pi radians, and what kind of shift do you think the graph has been made to get to the graph where it is now? So think about it. You now compute the equations, and then turn the video back on and think you have an answer. All right. So I kind of sketched the sine graph. I'll begin there, and the cosine graph I'll do second. So on the sine graph, 0 is at pi. So pi is actually right here at 5 pi over 4. So again, to get it to look like the sine graph, it means the graph itself has basically been moved to the right of pi over 4. So that means it would remain a subtraction problem, and the graph itself has been shifted pi over 4 to the right of where it would normally be, which is 0 is going to be pi. When you talk about the midline, it's kind of like when we did the shifting upward, the midline is kind of like the x-axis. So I always know if I have a sine or a cosine graph based on where the graph hits the midline. So that's kind of that would be the shift there. For cosine, what I'm looking at here is the again pi. I would be at, like, let's say -1. The -1 should be the bottom. So pi would be right here. That's at -1. So the graph has been shifted that much to the right, and so that would be 3 pi over 4. So I'm going from 4 pi over 4, which is pi, to 7 pi over 4. So I've shifted 3 pi over 4 to the right. So again, in both cases, I would do a shift to the right, which would make the equations, or those expressions, subtraction. So that I stick pi over 4 back into theta, I get a 0. I stick 3 pi over 4 in for theta, I also get a 0. So that would be the two equations for this situation. Problem 4 is an opinion question. Go ahead and answer that, and then move on to problem 5 when you are finishing. This is your opinion. What do you think adding a 2 in front of the x value in the parentheses, how do you think it's going to change the graph? And we actually, last class period, talked about this value, your delta math called the v value. You've already seen how the v value impacts the graph, so can you talk a little bit about what you think is going to happen? So with our delta math, we actually were given equations and actually graphs and that, and we actually came up with the equation based on looking for the period, the amplitude, and the midline. This is the first time you actually have been asked to graph this. So the equation is already graphed is y equals sine theta, and you're asked to graph 2 sine of theta. So if you would go ahead and do that, and then turn your video back on, and you are ready to continue. All right, so the question that raised in problem 7 is how does the two graphs compare? So if you've not written your answer number 7 yet, go ahead and do that, and then turn the video back on. So a couple of things. The graph hasn't shifted up and down, for example. In other words, the amplitude hasn't changed, so it hasn't been stretched. It hasn't shifted left or right, actually. What happened is that for this one right here, basically the period is from 0 to pi. So that's where you start the graph, and then it starts all over again at 2 pi. But for 2 pi, it actually starts over. It goes from 0 and to pi, and then it starts all over again. So by doubling, by putting 2, which we call the b value in delta math, and next to the theta, what's happening is that the period itself is half as long as it was originally. Or you're going to basically do 2 periods to the 1 if you compare sine of 2 theta to sine of theta. So a period is half as long or 2 periods in the same time as sine theta goes. So in the last 2 problems here, if you would sketch the graph, you may want to create a table very similar to the one that's above. If you want to mark out, for example, sine theta, or take and draw another line underneath the values here. If you want to do y equals cosine of 4 theta here, and use the same values, and then graph those. Might find that to be helpful. And then turn the video back on again when you're finished answering 8 and 9. So if you would have used the same values, hopefully you notice that the graph is returning back to -1 and 1 quickly, and then, which means 0 would have to be between pi and pi over 4 and pi over 2, and then 0 would have to be between pi over 2 and 3 pi over 4, and so on. So 0 has to occur in here as we're going back from -1 back up to 1, and then back down -1, and so on. So keep that in mind if you haven't done the graph yet, that 0 is occurring here still. You're not jumping over 0, it's just that it's occurring between these answers. All right, so for cosine, a 1 period is from 0 to 2 pi. For cosine 4 theta, a period would be 0 to pi over 2. So starting here to here, that's first period, second period, third period, and the fourth period. So we completed, we're getting started on basically 4 periods. So you're starting basically four of this shape here. This occurs 4 times. In the same time, cosine theta does it once. So sine, basically we have 2 periods when you have 2 theta. Cosine, we went through 4 periods.